right, we're back with some more substitution method questions for systems of equations, and we're looking at two setups of equations, one of them which has a variable by itself, which allows for us to use substitution method. So we're going to take what y is equal to, in this case it is 2x minus 5, and what we're going to do is with the other equation, we are going to substitute that y value, which is right here, and we're going to plug this whole piece in place of that y. So we only have one variable that we are solving for. So what I'm going to do is I'm going to rewrite the second equation, and I'm just going to put minus because that's what we start with. And then where we see the y, I'm going to put this whole piece that we have 2x minus 5 in parentheses in replacement for that. Because again, this is what y is supposed to be. And so those two pieces are what it represents. And then we're going to go ahead and we're going to solve for x in this case. So now that we have this, what I am going to do is I do have this minus, which does apply to both items inside the parentheses. So we are going to distribute it to both items. So we've got 4x, and then this negative times x, 2x is going to be a negative 2x. The negative times the negative 5 is going to actually make that a plus 5. And then now we can start to simplify this a little bit more. 4x minus 2x gives me 2x plus the 5, which is equal to 7. And then we want to get x by itself. So we're going to subtract the 5 on both sides and then get x by itself on that last step by dividing both sides by 2. And x is equal to 2 divided by 2, which is 1. So now we know x is worth 1. So now we're going to go up to the original two equations here that we have. It does not matter which one you apply it to. It does make a little bit more sense to put the x in replacement for the top equation, just because everything will then be solved on that right hand side, which will get me what I have for our y value. So I am going to go back up to that original and just replace the x part with the number 1 in it and solve for the y. So 2 times x, which is 1, and then we're going to do minus 5, and then just order of operations, y is equal to 2 minus 5, and that gives me a negative 3 for my y. So now I know that my x is 1, my y is negative 3. I do want, obviously, to check, make sure, as in all algebra problems, that we do check to make sure that it does validate in both of the equations. So we obviously know it does work for the first one because we just plugged it in and solved for it. So we know that 2 times 1 is 2 minus 5, which gives me that negative 3. I do want to go back up here and check it with this one. So 4 times 1 minus that negative 3. So minus a negative is actually plus. So we've got 4 plus 3, and it does equal 7. So I do know I did this correctly. So now I'm going to just get my answer and write it in coordinate form. X comma y, so our 1 comma negative 3, and that would be my answer that works for both equations to make them true. And if you want more questions like this, you are welcome to follow me on my YouTube channel, You Want Algebra. Check these out under a new section that I'm going to be replacing. It's going to be the systems of equations, but this is going to be a separate substitution method section so that you can find those videos a lot easier, and in that way it's separated out by substitution, graphing, and the elimination method.